Math and Beats. Welcome back to another video, and we are going to continue discussing all this logic and proofs and stuff. And in order to do so, we need to talk about sets, which we haven't done so far. So we're going to introduce sets in this video. Let's get started. Straight up, what's a set? A set, by definition, is collection of objects. So you just have a bunch of stuff, and that collection we call a set. Now, in the mathematical setting, the objects that we deal with are usually numbers, but they don't have to be. So we're going to see some examples in this video as well, how to use the sets with some numbers. Collection of numbers. Set. Type of set. Now those things in the set, the members, whatever they are in there, numbers, rocks, whatever, we call them elements. It's just a vocabulary word. So the members of the set are called elements of the set. Some notation that we will use to denote elements is down here, this symbol. I'll write it a little bigger. It looks kind of like a curvy capital E, and it literally means element of. So if we want to say let S be a set, and you say, well, what's in this set? Maybe X is in this set S, then we could write X is an element of the set S. It's just notation. So we'll use that notation moving forward. And there's another example right down here, just like I just said, except say A is an element in the set A, big A, then we would write little a belongs to the big A, element of big A. Now, what if we had what that was not in a set? For instance, what if we got this variable B, number, object, whatever it is, and is not an element of the set A? Correspondingly, we would write B is not an element of the set A. So what do? You just take the element symbol and you negate it, essentially. B is not an element in the set A. All right, so some notation. So basic vocabulary. Sets are collections of objects, and the objects that are in the set are called elements. And we got this way of denoting whether or not something belongs to a set or doesn't belong to a set by this symbol, the element symbol. Now, what are some introductory ways to write sets? Very common two ways is we either use braces, not the things that go in your mouth. These things, braces, curly brackets, whatever you want to call them. That's a way that we're going to use a collection of objects. We also use interval notation. There's another entire video on interval notation in the math folder. So if you want to know more about that, you can. But we're going to focus on using the braces right now because if you may recall, interval notation is reserved to collections of real numbers. So we're going to wait for another video on more on this. So what are the two ways that we write them using these braces? There's one which is called listings notation, and we literally list the elements in the set by just straight writing them out. All right, so you think about how this works. Here's your braces, right? And we just write what's in the set. Maybe what's in the set is 1, 2, 3, 4, right? So that would be the set containing the numbers 1, 2, 3, and 4. Think of your braces like a box. So stuff goes in there, elements go in there, right? And you say you had a box full of rocks, box of rocks. You could think of the box itself as the braces symbol, and then all the rocks inside the box as your elements of the set. Just an analogy. So you can list them out. That's listings notation. And there's another notation or another example right down here real quickly is very similar to what I just wrote, except consider you have a set A here that consists of 2, 4, 6, 8, and 10. So the elements of the set A are 2, 4, 6, 8, and 10. And then you could literally write every single one of these statements right here is that 2 belongs to A, 4 is an element of A, 6 is an element of A, and so on. So that's it. Those are the only 5 numbers in the set. Numbers like 3 and -1 are not elements of the set. So you could say things like down here, 3 is not in the set A, -1 is not an element of A. So there's 5 elements in the set. So that's a way to use listings notation. Again, just list out what's in the set. But, you know, think of situations where you may have too many things to list out and it may not be efficient to list the elements in the set. That's some yummy coffee right there. So, you know, if you have infinitely many objects in the set, for instance, how would you list them all? Something like that. Or what if you had 5 billion? So we got to have another notation to help us out in situations like that. It's more convenient when we have such situations to use what's called set builder notation. And like I said, this is a good notation. You could always use it in any circumstance, but it's most commonly used when you have, say, an excessive amount of elements in the set. It's just not feasible to list them all out. So we're going to also use braces in this notation. That's why it's in this discussion. And the general form of a set using set builder notation is going to look like this. So what does it say? At the very first part, you just put what type of elements are in the set. Usually we say it's some variable like all the variables x's that are in this set. And then you put a colon. So the colon there literally means such that. So what's in the set? Some stuff x's such that, and then you put conditions on the elements in the set on the right side of the colon. So for instance, maybe x has to be positive. You would write something like over here like x is positive. So a set containing all these x's, any x value such that it's positive. So that's how we write out the listings notation. And there's another example right down below. Let's just say you want to write the set of positive even whole numbers which are less than 1,000. Then you could write out the set in set builder notation. Let's just give the set a name A. A is the set that consists of all these x values such that x is 2 times some integer k, where x has to be between 0 and 1,000, but not including the 0 or 1,000. So the big thing for this notation, just write the variable first, colon for such that, and then write the conditions on the set. Don't forget to put the braces on both sides. All right, so a couple of examples before we wrap up the video here, just to get the idea fully across. We're going to look at 2 examples, and in each one we're going to write the phrase which is describing a collection of objects of a set, either using listings notation or set builder notation accordingly. And we think about why we would use one over the other. Again, you can always use set builder, but if it's easy to just list out the elements in the set, then that's usually the way that we would go about it. So this first one here, we want to look at all of the prime divisors of 528. So essentially we have to find its factorization, and it is known that the factorization of 528 is 2 to the 4th times 3 times 11. And so what are the different prime divisors that occur in that factorization? It's the number 2, 3, and 11. Those are all prime numbers which divide 528 evenly. So we just literally list them out. There's only 3 elements in this set. So we could say, oh, it's the set A, which consists of the numbers 2, 3, and 11. And then a thing to note is that, like I said, a moment ago, you can always write it using set builder notation. And in this case, if you did, you would write, okay, it's this collection of numbers, x's, let's call them, such that x is a divisor of 528. So though that is a way of describing this set, it doesn't, explicitly say what are these numbers that x is a divisor. It really should say prime divisor of 528. So you see, it's like, well, what's more efficient in this situation? Take your pick, but I would choose the listings because there's only 3 elements. How about part B here? All students at Foothill College whose height is greater than 6 feet. So we want to have a set that is all these people, all these students. So you say, well, how many students are at this place, Foothill College? Who knows? Let's just pretend it's 5,000. Then you got to think there's a decent number of people that are bigger than, taller than 6 feet. So probably a lot, probably too many to list. And moreover, how are you going to find all these people's names? So for this reason, we're not going to be able to really use listings notation. Instead, we would use the set builder notation. And what will we write? It's this set, this collection of x's. What are these x's? X is any student at Foothill College whose height is larger than 6 feet. And it's set. There's some stuff in there. We'd have to have more data to really say specifically what's in there, but we know it's going to be all these people. Okay, that's it for this video. Introduction to sets and introduction to a couple of different notations using the braces. In the next video, we are going to look at various ways of chopping up sets and combining them and things like this. So that's it. End of the video, and time is up. Until next time.